So, welcome to the Allora Research Fireside Chats, where we're exploring key ideas that shape decentralized machine intelligence and AI. So, today we're going to take a step back from applications and dig into something more fundamental. So, what exactly is intelligence? How do we define it? How does AI fit or not into that definition? And where might AI be headed next? So I'm joined by Diedrich, our head of research, and Diedrich's been exploring these questions through the lens of decentralized machine intelligence. Hey, Diedrich.
Hey, Steve.
So I thought we'd start with really from the basics. So before we get into discussing sort of intelligence and machine learning, we need to understand what is intelligence and how does AI meet this definition?
That's probably one of the most fundamental questions and maybe also existential questions you can start with, right? Is what is intelligence is in many ways something that just tells us apart as a species, lends us part of our identity. And for that reason, it's actually a very challenging question to answer. And it might not surprise you, of course, and you know this, that if you look at the scientific literature across different fields, there have been like careers built, destroyed, and ruined on trying to answer that question. Um, I personally really like a definition that was put forward actually quite some time before the current AI boom. Is a definition that was put forward already in 2007 by Legg and Hutter, who basically attempted to sort of formally express and define intelligence, or specifically machine intelligence, right? So basically what we consider to be the groundwork for AI. And it actually what is good about their definition, it connects to what you would maybe intuitively define as intelligence, and that is basically intelligence is an agent's ability to achieve its goals in as large a variety of scenarios as possible. So you can imagine maybe that there are some models that are like a chess engine, for instance, is very good at solving the chess problem, but it is pretty awful at trying to, solve language or interact meaningfully in any other ways or solve any other types of problems. So basically, there are two key ingredients that you need to combine here. One is the complexity of the problem or the range of environments that you can operate in, and you also need to define then what the goals are and what the rewards are that you achieve from optimizing your goals in these different environments. And basically, if you manage to do that, then you could argue reasonably like, okay, an entity or an agent that can maximize these rewards in a way across as many different environments as possible is clearly versatile. So it's adaptive, can adjust to different circumstances, which, interestingly also expresses a form of evolutionary fitness. But it is also, then when it adapts, it's highly successful. And I think that is a form of combination of scope and depth that lies at the foundational layer of what we consider to be intelligent. So it's this combination of maximization and doing that basically in any situation possible, including very complex situations. So no matter how complex the situation is, also operating on different timescales. Some of those situations might require short-term planning, others might need long-term planning. And basically, if you have an agent that's able to combine all of these different things, then potentially you're looking at one that is intelligent, and that can apply to humans, it can apply to animals, and it can apply to machines, because basically in this concept it's almost reduced to like a single mathematical model, and that is how you can then sort of get to the essence of that.
Yeah, no, I think I really like the paper, the Legg and Hutter paper. I think so. Basically, boiling it back to what you're saying here, I think the fundamental thing, or what I took from that paper, is that you've got an agent and the environment. That's
Yeah.
what it boils, and you can put any any type of intellectual problem in that situation, you can ask how well does that agent do in the environment. And I think one of the key things that there is this idea of feedback or a reward given. So there's a task that has to be done, and you've got your agent sitting in the environment. It's got a task to do. It needs to get a reward back to understand how well it's doing. And in order to be able to do the things that you were talking about farther forward, I like that very concrete, basic thing that you can test and see how it does on larger and larger, more and more complex environments. So going back to your chess model, the chess agent working in a chess environment is going to smash any player it comes up against if it's good enough, but it's going to fail another one. So that would fail the intelligence criteria because it does well at a single task, but is unable to operate in complexity. So I think that is a really interesting way of setting the framework for this discussion.
Yeah, no, I agree, and I think what you're highlighting there is actually quite interesting too in the context of modern AI, right? Because the current AI boom is really driven by reinforcement learning. And that is basically saying like, okay, the model while training gets a reward for certain behavior, and that is how it learns how to behave, like what the inference should be under differing circumstances. And of course, this definition kind of links to that. It also links to potentially how intelligence might have evolved in life, right? Because fundamentally, life is continuously subjected to, like a reward feedback loop in a way.
Yeah.
And that analogy might be more than a coincidence.
Yeah, totally agree. So they in this idea, so they to try and sort of build on that, I guess conceptually it makes sense. You have an idea of an agent, the environment, and some measure of reward. They talk a bit about complexity as a measure of doing this, and the idea of sort of Occam's razor. So if you've got the agent's making all these decisions, and you can imagine a scenario where there is a solution, but it's incredibly complex to deal with. And so one thing that humans do naturally, we take it completely for granted, is that if there is a solution, we optimize for the simplest one. And so this idea in the Legg and Hutter paper, so my understanding is that they use this idea of the whole world of possibilities. An intelligent agent acting in an environment will, there can be an infinite set of possibilities, but they have a way of boiling that down to what is the simplest, the kind of Occam's razor. That is the optimum. So the Legg and Hutter have a sort of mathematical way of describing this and quantifying that agent A is better than agent B because it's able to get to that simplest Occam's razor idea. Yeah.
Yes. Yeah. I think, and that's the point, is what we sometimes, I think, in science sometimes refer to as elegant.
Yeah.
Elegant. Sorry.
Elegance. Yeah. Elegant.
Is that
Absolutely.
an elegant solution is something that sort of intuitively gels well, and almost without exception, that is the solution that satisfies Occam's razor.
Yeah,
It's the simplest
absolutely.
solution, and therefore we think it's elegant.
Yeah, and so we intuitively, what I love about the Legg and Hutter paper is it takes that and sort of boils it down to mathematic.
Yeah.
It's a way that you can take any system and it takes something we intuitively understand, and you can definitely say agent A is better than agent B because of this. So yeah, I like that paper too.
Yeah.
So I think moving, I guess, taking that further. So we've got some. If we take this, and I'm sure that there are other examples of ways that you can quantitatively measure something like intelligence. They do in the Legg and Hutter paper. But then, I guess what we've got this idea of defining intelligence, but what then distinguishes artificial intelligence from human intelligence? I guess things like creativity and reasoning are key here.
Yeah, I think that's a very good point. There are many things in my perspective that at least currently still distinguish artificial and human intelligence or natural intelligence. And creativity is definitely one of them. I've no doubt we'll also touch on several of the others. Creativity is something that you can express in different ways, right? You can, how do I best explain? Maybe yeah, one way of being creative is if you are capable of basically putting together different Lego bricks,
Yeah.
right? Is you would be able to say like, okay, if I want to achieve something, then I can take something from this sort of general topical area that I know and something from this other topical area that I know. And if I put these together, then I can solve a problem. And that is creative because you're not using your toolkit from just one domain, but you're actually combining toolkits from different domains. So that is creative. That sometimes is not something that anybody taught you,
Yeah.
but is something that you figured out yourself, right? So it's maybe not, an extreme insight that if you have built a carriage with a wheel and you need to lift something heavy, that you put it on top of the carriage, right? That it doesn't need to be revolutionary, but still it's creative because it's basically, yeah, it's combining tools from two different domains. That is something that AI does pretty well at this point. I think, any conversation with a large language model will demonstrate that to you, that hey, it is actually capable of just combining things from different toolkits. So that is one. But there are other ways of creativity that are maybe a little bit harder. So a second one is more towards exploration. So maybe you can define some scope within which you can try and identify solutions. And I think at the moment with the new GPT model, there's this hype on Twitter where all sort of well-known images are being regenerated in like a hentai style. This is an example of exploratory creativity where you have this clearly defined sort of conceptual structured space of possibilities where it's associated with a certain style, but you can explore what would I do with that style, and you can generate new things within that conceptual
Yeah.
parameter space.
So maybe something like, I don't know, like improvisation in jazz, for example. Like there's a set of
Yes.
frameworks for the key signatures and what notes are allowed and not allowed, and within that, like go nuts. And
Yeah.
we may connect more to someone's improvisation than someone else's, but there's a framework there, and it's somebody operating creatively in that
Yes.
framework. Yeah.
That's right. And that is also something that AI does well,
Yeah.
right? At least in the current state. But there is another form of creativity, which is, I think, something that AI doesn't do very well yet. And you could even wonder how well humans do that. And that is the ability to transform that conceptual space. The ability to say, well, yeah, I realize that these are the rules, but I'm just going to invent completely new rules. I'm just going to figure out, if I want to solve this problem, can I do it in such a way that doesn't actually rely on anything that's been done before, but in a way that, yeah, is probably alien to anybody.
Yeah.
That is something that AI struggles with a lot because it's trained on this training set and typically stays very close to a training set. So this is one of the reasons that I like calling AI or yeah, machine learning models or AI models basically expensive interpolation machines. They interpolate within their training set, and extrapolating is very hard. Now, of course, humans are very similar, right? Like we grow up, we have a life, and throughout, we gather all of these experiences, which together will define our ability to adjust to new circumstances and to solve new problems. But our initial solutions are always going to be very close to things that we've done before, and pushing ourselves to find new solutions that really transform solution space. That is something that, for most people is very hard,
100%.
and even for those people who are really good at it, is still like a non-zero energy effort. It takes a lot of determination and agency to innovate on a conceptual level. And maybe that is the type of creativity that at least for me personally, touches very, very strongly on what intelligence is.
Absolutely. It's the ability to take. So I think there's two steps here. There's, going back to the jazz idea. There's our set of rules, and you're behaving in those. Anyone can change the set of rules of music, but it will be something that's totally terrible to our hearing. You can't just randomly change the rule set. There has to be you have to change it in a way that is meaningful and provides a better solution. So maybe jazz isn't the best idea, but going back to someone like Einstein as
Mhm.
as someone who I think would epitomize what you're trying to say here, is to take a paradigm in physics and to completely come up with a different paradigm that was able to explain our understanding of the way the universe works,
Mhm.
um, with a completely different rule set. And it's that kind of ability to go beyond, but then come back and get more meaning from what was originally there in the first place, or at least equal to that meaning. That kind of creativity is, for most humans would struggle at that level, but
Yeah.
that's, the I think people operate on a more or less of that level, and that's something that machines and AI currently really struggle with.
Yes, I agree. I think the dimension of like something being meaningful is quite critical in this context. And you probably have to distinguish there between what might be meaningful to an individual and what might be meaningful or new or creative in all of human history, right? there,
Yes.
there is something different between a personal epiphany
Yeah,
and a
absolutely.
societal breakthrough.
Yeah, yeah, definitely. Yeah.
And maybe in some cases now, and I definitely sort of recognize that in some conversations I've had with large language models, is they are capable of transforming the rule set. Maybe for me personally, sometimes, but I've never seen them do that for humanity at large.
Yeah.
And that is the critical difference. Like, of course, it's easy to um, yeah, or easy. It is a lot easier to trigger an existential insight for an individual than it is for 8 billion individuals.
Yeah. But I mean, so it's basically saying that the first thing you're doing, if you have a chat to a large language model and that, gives you an epiphany, the point is that that idea already existed. It's not
Yes.
inherently a new idea. It's just that you didn't have it yet.
Yeah.
So, and that's transformative, and it's fantastic, and it's incredibly useful on a personal level. But I think what we're talking about here, what you first mentioned, was something beyond that, which is
Yeah.
taking a completely new idea or a new way of thinking that's never been in the history of humanity been written down or recorded, and that is really a whole nother step. And as far as I'm aware, that I'm sure people are working hard on this, but it's not something that AI is close to being able to solve.
No, not yet.
Yeah, just yet. Okay, so then why moving on to why is that? Like what is it that gives some humans, your Einsteins in the world,
Mm.
for example, what is it that gives them that edge, or what's missing in the current version of AI? Could it be something, related to perhaps consciousness? Is there an element of that brings this in?
That is probably yes, and this is very contentious. I think there are definitely camps when it comes to this question: how important is consciousness to intelligence? Maybe okay. Maybe I'd like to lead my answer to this question with something from my personal experience, which is when I think about a hard problem, and this, and I compared different days thinking about all kinds of problems. Maybe it's the same problem across different days. Doesn't matter. There are days where the mind is functioning well, and there are days where it doesn't really. And in my perception, a large part of that is actually related to elevated or decreased degrees of consciousness. When I feel conscious, I find it a lot easier to solve difficult problems. And for me, what it means to be conscious in that context is to be thoroughly aware of all information that possibly connects to the problem I'm trying to solve. It's kind of, I guess the way of expressing it is it feels like you become the problem, and therefore it becomes easy to see the solution. And if I look at just how human intelligence works, I generally also feel that if I'm in the presence of somebody who comes across to me as extremely intelligent, that person I would typically also attribute with a heightened degree of consciousness. And it seems, therefore, that consciousness is a form of integrating information. And kind of given the definition of intelligence that we were discussing earlier, it doesn't surprise me that that plays a very fundamental role in intelligence itself, right? If you say that intelligence represents the ability to achieve goals under a maximum variety of circumstances, of environments, then surely the efficient integration of information into a single sort of, in computer terms, in internal memory rather than on disk,
Yeah.
that allows you to sort of instantly see connections, instantly see these types of relations that allow you to solve the problem and maximize the objective that you have, reap the rewards. And for that reason, it doesn't surprise me either that, at least in our experience, of course, that intelligence and consciousness seem to go hand in hand. It might well be that both of these evolved or manifested themselves as part of the same evolutionary process. Like an evolutionary process would be that a species is more successful if it if it manifests itself intelligently, and at the same time it will be more successful if it maximizes integration and exchange of information. So the evolutionary feedback loop in terms of fitness is actually the same for these two things, for intelligence and consciousness. So from my perspective, it is almost inevitable that you develop both at the same time. If you can't integrate information,
Convergent.
yeah, it's convergent. If you don't integrate information efficiently, you cannot solve problems under a maximum number of circumstances. But if you integrate information efficiently and you can't put that to use somehow, then you're also not intelligent, obviously. So it seems like in many ways, intelligence and consciousness might be two sides of the same coin. Again, I mentioned before that this question is contentious, right? So I'm not saying that this is like the ground truth that all of science agrees on or anything. This is very much my personal perspective. But I think there is something to it. I'm quite convinced of that, actually.
Yeah, I'd like to delve in a bit more on that, and particularly your own personal insight. I definitely have moments like that, probably not as many as you, but where things just seem to click and everything's coming in, and you have that interesting concept. But maybe just to sort of dive into that a bit more of the specifics.
Yeah.
So I think there's a difference between sort of having information and what you do with it. I think that's kind of at the core
Yeah.
of what you're doing, because you can imagine. Let's just take something like a camera, for example. So a
Mhm.
camera's got lots of diodes, and but each of them are acting independently. And so you got a camera that's taking a picture of a situation, and you can have 1,000 by 1,000, and so it's a lot of pixels. And so the amount of information that camera can store
Yep.
is huge. It's absolutely vast. If you think each one can be a one or a zero, then the possible combinations are astronomical. But that's clearly not intelligent, because there's no way they're all acting completely independently. Each of those diodes, each pixel is acting independently. So there's no way that a camera could become intelligent. And I think it's really interesting linking that, because there's obviously a lot of work with people linking consciousness to what's going on in the brain. And the way the bits of the brain we think that are related to consciousness, at least as far as I understand it, is that the bits of the brain that work more like a camera are nothing to do with
Yeah.
consciousness. It's the bits that take those 1,000 by 1,000 bits of information, the neurons, but the fact that they're all completely interlinked and able to pass that information to each other, that's the key distinguisher. And that sort of links to you're saying kind of on a macroscopic scale, when you're in the zone, so to speak, when you're feeling super conscious, because you're taking all the bits of information, processing them and linking them together, synthesizing that. And it's quite interesting that sort of neurologically, they're the bits of the brain that are doing that, processing those bits of information that we think are most closely linked to consciousness.
Yeah, I think that's a great point. So indeed, it's the integration and the basically the networking, right? I think we
Yes.
actually
Yeah.
touched on this. I remember now we touched on this in the first fireside episode. Is that if you is that you basically you boost your intelligence by maximizing the connectivity across a network.
Yes.
Basically, enable the free flowing of information. Is basically coming down to this, and what that means is indeed is if you sort of you maximize the connections across that network of information elements, you're almost saying that at that point, I mean, that is kind of what we're converging towards, right? Is that at that point, that network could become sentient at some point. That is the hypothesis here. Now, of course, we're not touching on the sort of more obscure concepts of what the soul is and these types of things, right? But at the very least, sort of in a sort of pseudo deterministic way, you can say like, okay, there is maybe something related to that type of like maximizing network connectivity and at some point approaching a point of sentience through that potentially. And an interesting consequence of that too is if we now go back to maybe what I said in the beginning about my sort of personal perspective on how important consciousness is for intelligence. Um, what that means too is this question of is a certain species conscious or sentient?
Yeah.
That becomes kind of a moot point because the natural consequence of what we're discussing here is that any species is conscious to varying degrees,
Yeah.
right?
It's a
So,
sliding
and
scale.
indeed, and if I think everybody has had experience with maybe a really poor night of sleep, waking up in the morning and feeling groggy,
Yeah.
like that definitely feels like a decreased state of consciousness to me. But that maybe says something too about just how much of a continuous spectrum consciousness is, and therefore too maybe the therefore is a maybe how much of a continuous scale intelligence is.
That's interesting. I mean, definitely, like, if you ever had a general anesthetic, you know that consciousness is. I mean, it can be switched off, right? I mean, if and when you go to sleep at night, there are parts of the night where you're clearly not conscious. So, I mean, in terms of linking to the brain, or whether that, I guess your point of linking to intelligence is a whole other matter. But once you stop that flow of information, yeah.
Yep.
So yeah, I think that getting back to the sliding scale, I think there's the interesting paper by Tononi
Hmm.
that looks at this and again tries to take um, a sort of mathematical or network connectivity approach to the emergence of
Hmm.
consciousness. And it really links strongly with some of the things that you've been saying, where they take, I guess, the bits of these brain where everything's interconnected, um, and you can break that down. So imagine you've got your 1,000 by 1,000 neurons, and each set of neurons is interconnected in different ways,
Hmm.
and the idea of what I guess the seat of consciousness is the maximum um, scale over all those neurons over which you are maximally linked. And
Yes, I think what uh, Tononi touches on as well is that if you try and in that network you try and identify sort of critical links and if you disrupt that system through any one of these links and it really reduces the capacity of that network to exhibit different states, sort of different informational combinational states, then that means it is highly integrated.
yes, yeah,
So that too to me is very analogous to how the brain works. You mentioned that before, this sort of neurological motivation or analogy for how we're now in this conversation and more conceptually talking about consciousness. And, I'm not a neuroscientist, but from what I understand, these types of sort of critical points in the brain exist, right? Where, sure, you have an extremely high neuron count with highly connected networking between neurons, but still there are these sort of critical points where if you disrupt them, then indeed the sort of the state or the number of states. There was a name for this in physics. That's embarrassing because I am a physicist and I can't figure out the word. But it's basically it's at the bottom or at the foundation of entropy. Maybe you remember it.
This is the maximum.
Yeah, basically the natural logarithm of the number of permutations.
What
That
Boltzmann's?
that
Yeah, that
yeah,
is entropy.
it's basically an expression of the number of states you can have, and
Yeah,
that drops
yeah,
um, when you make that cut, and that is at the sort of essence of consciousness, according to the Tononi paper.
yeah, yeah. I think that's that the idea of the sort of that mathematical model and linking it to the brain. I thought that another interesting thing in the paper is this idea of like the quality. What's it like to experience blue or experience
Yeah.
red? Like that is something. And in terms of, I guess maybe something we'll touch on later, is it's something we completely take for granted. This idea of experiencing something that has to be linked with consciousness and the idea of this really integrated system.
Yes. I as a kid, I wondered, how do I know what I see as red is
Yeah,
seen by somebody else not as how I see blue?
yeah, yeah. Your
And
grass could be my red. Like, how good
yeah,
is
that's
that?
right. And the true answer is you don't. So, or at least not until we find a way of actually regenerating a form of reality from brain scans, right? So it's these types of things that could potentially provide insight into that. This also actually, I mean, you're touching on something interesting there, I think, which is that this sort of conscious experience of reality touches on many things, but also touches on. I think there's an age-old paper by I think Bowden from 1980
Yeah,
and he coins this Chinese room experiment, where you basically you lock somebody in a room who has no knowledge of Chinese as a question as a language, but you teach that person the sort of the rules of basically going from one character to another of potentially translating, doesn't matter, but you basically teach the person to manipulate the characters,
right.
and
So this
that
is Searle,
person.
the Searle experiment.
Searle, sorry,
Yeah,
not Bowden. Yeah, we were talking about Bowden earlier.
yeah,
You're right. Yeah, yeah, indeed. So John Searle,
yeah,
and you can teach that person to basically do this perfectly,
yeah.
to go back and forth between English and Chinese, so to say, and even idiomatically learn to do that perfectly. It's basically just a long, long list of if statements,
Yeah.
and that person will never understand Chinese, right? That person will just sort of learn the rule set. Like, look, if I see this symbol, it probably means cat, right? Or I can translate that to cat. But that person will not be able to express themselves in Chinese per se. That person will just learn the algorithmic steps without ever achieving a true understanding. And that means too is like if that person learns to do it that well, it passes the Turing test,
Yeah.
right? It can imitate and make a user believe that it's a real person, except it isn't, and it's not even somebody who can speak Chinese.
Yeah, yeah, absolutely. So I guess the having someone in a room, as long as they're not thinking too deeply, right? I mean, so if
Yes.
you have them and they're managing to learn, they see what comes in comes out, and it was a literal person that was able to learn.
Yeah, but then that person is building almost like a physical model of reality,
Yeah.
and that is fundamentally different, right? If you have a physical model of reality, then you're not following a simple rule set, but you're trying to achieve a form of understanding. Uh, yeah.
Yeah. I was just like when I think of the Searle thing, I always it's probably not how it was meant to be taken. But imagine if I was stuck in that room, I'd be pretty bored. And so when the when the symbols were coming in, if there was a way I could try, I'd be trying to learn Chinese if I was stuck in that room. I always felt sorry for the person stuck in the room. It
Me
take a
too.
long
It
time. I think
sounds
Chinese
very,
is quite difficult for non-native
yeah.
speakers.
It's just yeah, it's grim in general to be locked in a room and only have to manipulate language.
I don't want to be locked in a room ever, really.
No, that's better.
Yeah, so I guess just going back. So then going back to this idea of these what it's like to feel red or blue. I mean, I think
Hmm.
just sort of rounding that off, one thing that has always struck me is can you boil that down to just a single brain state? Like, is there a single brain state for me that
Hmm.
in that state that's my perception of blue? Is that I guess this idea of this qualia or
Yeah,
quality.
maybe. Um, I guess we won't know until it's technologically possible to test that hypothesis, right?
Yeah, I just think that's interesting because then if that's true, then if it is comes down to sort of single brain state, then there's no reason that that couldn't be replicated
Yeah.
somewhere else. If we could, set up a similar sort of new neurons and
Yes.
whatever in some virtual machine, doesn't have to be sort of physical neurons in the same way. Yeah, I quite like that.
Yes. Yeah.
Yeah,
But basically, I think what we see, to just circle back briefly, is
yeah,
that I think maybe that's the lesson of this Chinese room experiment, is that there has to be a form of intentionality to call something maybe more conscious or more intelligent. I'm almost using intelligence and consciousness as
yeah,
synonymous, which they're not, obviously, but I think it applies here again to both as well. Is that intentionality is kind of mission critical for both. Is you can't just be the cheap interpolation machine or
yeah,
expensive interpolation
yeah,
machine, even in order to be truly intelligent.
yeah.
I
So
think that is what we learned there.
yeah, absolutely. So I guess maybe pushing, changing angles slightly. So we've covered a lot of ground. We've covered, a definition of how intelligence and how you might measure it in terms of the Leg and Hutter paper. We thought that creativity is interesting here. Thought a bit about the brain and neurons and the Searle experiment.
Yeah.
Let's be interesting to go on to like what the current AI systems. Okay, so we've got, I think everyone's got an idea of what intelligence is, and there's probably concepts like creativity and
Mhm.
consciousness are there. But what are the limits of current AI systems, and
Mhm.
particularly things like generalization and context reasoning? So what is it that we do well that humans that machines don't?
Yeah, I think I gave a sneak preview on my thoughts on that in the previous
Yeah.
discussion point, I think, which is when we try and understand something, we build a physical model of reality.
Yes.
And amusingly, that model representation actually might be quite essential to our ability to extrapolate rather than interpolate. Because if you have a physical model of reality, you can do thought experiments,
Yeah.
right? You can say, let's try this to this concept I have in my mind. And then, that thought experiment might tell me how something will work. And then I can apply that in reality and make a prediction. That is, in many ways, can be used also to extrapolate, to transcend, to go beyond the training set. So that is a key element there, right? Is if we go back to the Chinese room experiment, people are not just pattern recognizers, and the same is probably true even for um, reasonably intelligent animals are not just pattern recognizers in that sense, but are actually themselves building models.
Yeah, like
And children do the same, right?
100%. Yeah, and
Like
I think
children.
yeah.
Sorry, go ahead.
Yeah, no, go on.
Well, children learn things by generalizing, and that act of generalizing is because they build a physical model, like the way how they handle physical objects, the way how they interact with the world is actually very deeply rooted in what their experience of the world is. But then there is also this translational step to how you expect the world around you to respond to your presence, and that exists in the physical world, but it also exists in sort of the intellectual world. Like the moment you start thinking in terms of systems, like you basically you build a set of axioms, and then at some point you put these together, and you start to identify. And I think this is maybe very important. You start to identify cause and effect.
Yeah.
So if I press this button, then the alarm will go off. Or if I press this button, my laptop will switch on. Or if I press this button, the stove switches on and I burn my fingers.
Not a good idea. Yeah.
These are all causal things.
Yeah.
And yes, there is definitely a part of pattern recognition in these sort of simplified examples that I'm giving. But complex causality absolutely requires a form of intelligence and generalization that goes well beyond what AI can currently do. I think in the weeks since we recorded the first Fireside episode, vibe coding took the world by storm. And I think anybody who has been trying to vibe code and use large language models to build software for them, of course, are impressed by the potential of this approach, but must at some point when they start asking critical questions and want to move beyond a proof of concept, must also be frustrated by the lack of basically causal reasoning
Yeah.
in these types of models. Like especially when the problem gets complex, it is extremely hard. And then this is where human critical thinking comes in. It's extremely hard to identify the causality, and that is something that I think humans over time, and over time I don't mean evolutionary time, I mean lifetime, become quite good at. Is humans, and this is it's existential for humans. Humans have learned to learn.
Yeah.
It's mostly what children do in school is they're of course they're learning that 2 + 2 doesn't equal 5, but they are most of it is about learning how they can pick up new concepts and start building that physical model of reality in such a way that it can be constructively applied in the future. And that is really the essence of learning. And then they can start mapping out complexity, causality and complexity, sorry, is what I meant.
Yeah, and I think it starts at a very early age for humans. Babies, they learn things that we completely take for granted. Things like the permanence of object, like the fact that I put a ball here and I put a bag on top of it and I lift it up, the ball's still going to be there. That is something that we just take so for granted. But where I think my reading is when I was looking into this is that that's really hardwired from a very young age, and having concepts like that to build on and construct an idea of emotion. If I push this ball, it's going to roll, and humans are able to pick up on that and understand. Well, there's a curve on the table. The ball's going to go one way or another. So that idea of understanding laws of motion, of course, that was critical for for us to be able to survive all these things. But the fact that they're hardwired gave an evolutionary advantage, but that is I guess the foundation for this building of the models that you're talking about that enable humans to take a situation they've never experienced before and apply these same rules or logic or things that they've understood and enable it to generalize and understand how, if I put the hob on, to use your thing, if I put the hob on you and heat it up, I'm going to burn my finger. If you gave them, well, hopefully an adult, maybe not kids, but an adult, if you gave them a camping stove, it looks very different and it behaves differently. It's gas instead of electricity, but the principle of heat transfer and ow is, directly because they've learned from that, and that's, doesn't take learning in a complete new environment, whereas a machine would have to, relearn it, or that concept is much more difficult for a machine to learn. Whereas I think we're pre-programmed in some way to build this physical model, and helps with generalizability.
Yes. Yeah, I completely agree.
Yeah, I think other ways that things that people are trying to on a similar topic within sort of building AI and a sort of AI development, things like transfer learning. So this is something
Yes.
that
Yeah.
is at the core of trying to improve models. You train it in one set of environments and use that as the basis for another one. And this is something again that humans can do so much easier. If you learn how to play tennis, for example, then going from tennis to squash is super simple, right? For
Yes.
human, that's almost trivial. It's hitting a ball, and instead of going over like a net, it's going against a wall. But doing the same thing for a machine would be a very different, sort of involve a lot of retraining, and the generalizability, and as you say, the fact that we have models and are able
Mhm.
to sort of put it all together is a key difference.
Yes. Yeah, fully agree.
So then, how do we get that? Like, what is the key thing that distinguishes a human from being able to play tennis and squash, or learning about their environment, a ball rolling, and it's going to go left instead of right? Is part of being in the environment key here? This idea of, I guess, embodiment.
Yes. I think we've kind of been dancing around that,
Yeah.
but I think embodiment is actually much more important than a lot of people are willing to admit. Um, and the reason, again, it sort of comes back to a lot of the things we discussed. The Chinese room experiment is that, in a way, the fact that there exists a physical self means that you can that you can start building that mental model of reality. The fact that there exists a self, and that self is multisensory, right? So we feel, we see, we hear, we smell. These types of things are basically enabling a form of information integration that leads to consciousness. And by putting all of these together, we're maximally capable of maximizing our objectives across as many different environments as possible. I struggle to see how taking away embodiment could in any way enhance our ability to do all of these things. In many ways, I think actually embodiment is maybe the finishing touch there. And if you now try to imagine how you would do these, how you could do these things if you had no experience of reality, then you realize that very quickly you go back into the Chinese room. You would end up trying to do pattern recognition. You would try and interpolate on that, and maybe even on a very daring day, extrapolate a little bit. But it's not clear how successful that experiment would be. So, does that mean that embodiment is a necessary ingredient for intelligence? It's just really hard, right? Because we're now arguably at the first time in human history that we can even have this discussion. If I think back, maybe 100 years, this was a totally ludicrous question. What do you mean intelligence without embodiment? That makes no sense, right? It took computers and then the ability to develop relatively capable algorithms for these computers to even start asking this question. So naturally, the road towards answering that question is a bit of a minefield, and uh, and of course, these are now questions that are starting to be asked since the beginning of computers, pretty much. And I think in recent years, with the current AI boom, the urgency of these questions has only been amplified further. Um, and maybe a way of looking at this is that there were definitely different types of problems that some of which might benefit more from embodiment, right? There are some problems that are you know things that are more abstract probably don't rely as much on embodiment. Like, moral values might be one, or law, or these types of things.
That's interesting.
Um, but there are others where embodiment really gives a very persistent boost to the ability to answer these questions. And then if we go back to what we consider to be the definition of intelligence, which is maximize the objective across as wide a variety of environments as possible, then surely I would want the sort of embodiment type problems to be well represented there too. So yeah, it's definitely possible to be intelligent without embodiment. It might be a lot less so.
Yeah, and it would be just much more difficult. If you're sort of truly embodied in an environment, I'm thinking, again, in a human sense, but just the rich complexity of data that
Yep.
we are taking in through all our different senses. I mean, it's a vast amount of data, incredibly rich. It's not structured data, and
Yeah.
so being able to deal with that and process with it is just trying to give a system or an agent that level of information to come up with similar dealing with in a similar way would just be you know I don't think impossible. I don't think embodiment is strictly necessary, but I think it helps massively. It's a good sort of structural um, sort of key facilitator or enabler. And it's going back to what we were talking about right at the beginning with this idea of Leg and Hutter. It really closes the feedback loop in terms of an action, a perception, a prediction, or the observation and action and reward in Leg and Hutter. So immediately in a very, very rich way that I think just enables development a lot quicker than you would have without all of that information. But I think, I
Yes.
mean, yeah. So Steven Pinker, I think it was him that said that just because a baby learns with body doesn't mean that AGI has to. So I think
Sure.
is a
That
fair.
is true. Although I've been thinking in this context as well about the role of AI in education, for instance, right?
Mhm.
Where, we're definitely, it's not too hard to imagine a future where every child has its personal AI tutor. And you can wonder to what extent such an AI tutor can, like, sure, so many concepts it can explain well, but it will always miss the lived reality of the concepts it's trying to teach. And that is interesting, right?
Yeah.
Is the imitation game so good that that is not a weakness? Then maybe it's fine. But a good kid, a very hungry student, will ask questions until the imitation game breaks. And the question is that point inevitable? Or will AI be able to develop at such a rate that the human curiosity and hunger for knowledge can't keep up with it? And basically, children, or even older children like us, uh, asking
Oh,
questions
yeah.
might not be able to push it to that breaking point anymore. And that is not obvious. I mean, we will need to see.
So Yeah, it's absolutely fascinating. But I mean, another way of looking at it is in a kind of we've in my head at least we've got you know, your concept here of a digital tutor, and I've got this silly picture in my brain of a brain sitting in a vat that you can keep asking questions, but it's literally a brain in a vat, and can
Yeah.
that ever come up with a concept that will outpace humans, or is embodiment crucial? But is there another angle to this about being you know decentralized intelligence is where I'm going with this. Is that how does that fit in with everything we've been seeing? So I in my head at least, when I've been talking about this, I'm just naturally I have this concept that we're really talking about a single agent or a single brain or a single system. How does the idea of decentralization fit within this whole broader topic that we've been discussing?
Yeah, that's a very interesting question again. I think just to circle back briefly on what you said before is, to me, decentralized intelligence is very much like a brain in a vat, because embodiment is pretty hard to do in a decentralized way. Um, I guess our definition of multisensory experience, which for us is just coming from a single body, right?
Yeah.
I guess multisensory perception of reality could be amplified to an enormous extent in if you add decentralization to this, right? And you're no longer talking about like an Optimus robot. And I thought that was actually interesting in the context of the previous point is
Yeah.
if you put a large language model in an Optimus robot and compare it to one that's just running on your laptop, which of the two is more intelligent, right? It is relating to this idea of multisensory information, integrating all of that in terms of consciousness and so on. Now, if you start porting all of that from that simple question to a decentralized network, then it isn't hard to imagine that all bets are off.
So just yeah, putting this in context. So in terms of decentralized, we're talking here about there may be an agent sitting in one location, another agent in another location, and they're all interlinked. And also there's this rich diffusion of data from they're all kind of linked in some way that is fully connected. Is that what we're talking? Just to get across this concept of what we mean by
Yeah,
decentralized.
there are multiple forms of that, right? So uh, if we look at for instance Allora, right, which is a decentralized machine intelligence network, which is privacy preserving, which means the individual models training data are private and it's only actually the inferences that are being shared. Then obviously what you have is a form of emergent intelligence that touches very strongly on this concept of like what does intelligence look like if you start distributing it. Can it grow? Can it become multisensory and so on? But it doesn't fundamentally satisfy this information flow definition of consciousness, right? Where if you wanted to achieve that, then the model states and the training data, the feature data would need to be shared across that network one way or another. So privacy preserving networks are not naturally inclined to maximize consciousness. Doing anything more than a privacy preserving form in a decentralized way is challenging because basically at some point communication and data flow becomes really limiting. So on the one hand, I think that yes, indeed, decentralization can potentially, if there are no physical limits on the flow of
That's the key.
information,
Yeah.
then I would say absolutely. Then the decentralization of intelligence. If we just assume that artificial intelligence can over time start ticking all the boxes that human intelligence has been able to, which by no means is a given. We don't know that, but let's say it can. Then quite obviously, without any such physical limitations on information flow, decentralized intelligence would be the highest form of intelligence. Skynet is real. There would be no question about that. But there were a couple of ifs
There
in that.
were a few important ones along on that,
Yeah.
logical statement. Yeah.
So it's not obvious to me that there are no physical limits on the information flow. It's not obvious to me that AI can indeed achieve this sort of form of intelligence that we've just been really like carefully pulling apart and trying to define what the building blocks are of intelligence. And when we do that, we see that there is actually quite a number of them that are not currently achievable for AI. So that means that a lot of that is to be seen. But yes, if we check all of these off, then I think there is no question. Then decentralized is going to outperform anything else.
Yeah, absolutely. And I think you're 100% right with the idea of this, the physical limitations of the system. Like there's a reason why our thoughts aren't instantaneous. Like we can measure that. There's a response time. We get some stimuli, and you measure what the brain does, and it takes a certain amount of time for those neurons, for the information to come in, the neurons to fire. You're conscious. Well, there's probably a subconscious things happening before, and then you're conscious.
Mhm.
All of that takes some finite amount of time for it to happen.
Yeah.
And the bigger, and it's just getting information from A to B. So from neuron A to neuron B, they're tightly packed, but there's physical limits that will be difficult to overcome in that sense. Speed of light being one.
Yeah. Yeah. I think speed of light is probably fine because at least for now we're still within well less than a second of light travel time. But maybe what is more challenging is the information processing, right? That is probably where most of the lag shows up, and that's what you said about neurons needing to fire up and so on. There are mechanical or electronic analogies to that as well, but that then kind of begs another question, right? Because there was a great book which I'm halfway through at the moment. It's called Ways of Being. I actually forgot the author right now. It eludes me for a moment, but it's called Ways of Being. It's basically looking at intelligence and being in this way. Is like, do there exist different forms than the one that we sort of naively think about? Talks about how, for instance, intelligence is being tested in animals, and that often we're way too anthropomorphic or anthropocentric in how we try and test for these things. And the same will apply when you look at decentralized intelligence, because if there's anything unhuman, it's decentralized intelligence. We are as beings supremely centralized,
Yeah.
because we have one body and that is it. But if you now have to think about ways of being intelligent in a decentralized way, then almost automatically, by asking that question of like, what would that look like, you need to think of intelligence as a concept that maybe exists in different ways too, even like on Earth right now. If you talk about ants or termites,
Yep.
bees, we talked about during the previous fireside episode. Especially in insects, I think this form of sort of emergence is very prevalent, of course, right? And if I look at the giant termite hills that termite colonies can build and how extremely intricately designed these are by nobody,
Yep.
because the termites are just operating based on simple rule sets that somehow, I suppose, evolutionarily were orchestrated to lead to this termite hill mound. Then it is extremely attractive to attribute a form of intelligence to that. Although, of course, those insects are very dumb.
Yeah. So
So,
where do you stand on that? Like, is it the collective that? Sorry, this is a tricky one.
yeah,
I mean,
yeah, it's
I
hard.
think anyone's going to have an issue dealing with this, but I'm interested to hear what you think. Like, I think we can probably all agree that an individual termite is not going to win Mastermind or a quiz show. Um, and even if you put 1,000 of them in the same quiz show, that's not going to help. And yet they can build these remarkable structures that look intelligently designed. So what's the answer here? What's going on?
Well, I guess if we go to the original definition of intelligence that we've mostly been adopting here, which is about maximizing your objective under as many environments or circumstances as possible, then I would say a termite colony, so not even an individual termite, but a termite colony, is pretty similar to a chess engine in
Yeah,
that it is very suitable to solve a single problem,
it's
but
optimized
no
incredibly
others.
well for their
Yeah,
environment. Yeah,
yeah.
but
And for that reason, you wouldn't call it intelligent.
yeah,
But now imagine a termite colony that sort of through these rule sets in an emergent way um, can solve any problem.
yeah. That would be so. If all the termite mounds could somehow collectively, interconnect. But yeah. So then going back to this idea of decentralization and linking it to intelligence. So imagine, let's say we can overcome all the information barriers, we can overcome
Mhm.
the transfer of information barriers, and we were able to connect, all of there's a vast amount of computing infrastructure already on the planet, and that's only, exponentially growing. Then is there a fundamental reason why it wouldn't? So they wouldn't the computers themselves wouldn't be embodied. So that if and but I think we've already agreed that isn't strictly necessary. It's helpful, but not strictly necessary. But they could be plugged into all of the sensor data. There's a vast amount of sensor data that are coming in. So why? What would it take for that to become sort of generally intelligent?
Well, I don't want to bury embodiment just that easily,
Okay.
because multisensory information will obviously be way greater for a decentralized network that can just you know not just feel the room that I'm sitting in or that you're sitting in, but countless rooms across the world and actually maybe even the entire planet. Um, the information integration there is yeah, infinitely greater.
Yeah.
Still, it's not clear what a lived experience is for such a system. It is not clear what that lived experience could potentially add, right? What a physical or a mental model of reality would mean in that context. So let's say, okay, this decentralized system would be able to do all of these things. Then you're approaching something that's very close to a hive mind, so to say, right? And you could even wonder to what extent our minds aren't hive minds, because quite fundamentally, we are a collection of cells that are collaborating. And probably, if you look at evolutionary history, that is that's how intelligent or the brain evolved. That's how the senses evolved. So if you put all of these things together, then there is no a priori reason why a decentralized form of many actors could not be intelligent. In fact, might be more intelligent than the sort of single system solutions that we've been building. Having said that, on the algorithmic level, current AI is often a network, right?
Yeah.
So therefore, the question is, what do you gain by just making the AI decentralized? Is it like on the fundamental sort of algorithmic level, you're not necessarily making things more intelligent than they might be otherwise. But what you can achieve is this form of collective intelligence, where maybe you and this is kind of, if I think about it, this is kind of the foundation, the fundamental concept of Allora as a machine intelligence network, is the recognition that some nodes are better at some things than other nodes. Basically, there exists a form of contextual outperformance for individual participants. And the moment you acknowledge that plurality between participants or nodes, or yeah, let's just call it nodes within a decentralized intelligence network, then you automatically must conclude, given the right algorithms, like we've been developing for Allora. And I won't repeat them here. Like, anybody interested can definitely check back to the previous Fireside episode. But maybe in very brief summary, the idea that you have an algorithm that basically learns to predict which nodes do well under which circumstances and when, that form of integration is definitely in the definition of intelligence that we're using, capable of maximizing the objective under a wide variety of circumstances, much, much better than anybody individually would. And that ability to leverage this greater variety of qualities amongst nodes in a decentralized intelligence network, that ability, therefore, naturally greatly enhances intelligence. And in fact, as you grow that network over time, it could even become unbounded. So that is maybe one of the main reasons why decentralized intelligence is going to be on pole position once the sort of obvious technical hurdles get overcome, which is the ones we talked about at the beginning. Here is a communication lag, bandwidth limitations, these types of things. Like these need to be overcome. But then you can go to this sort of distributed, context-aware, totally attuned system that indeed doesn't just maximize the objective under each individual circumstance, but also its own ability to solve that problem or that situation. So basically, the optimization step isn't just in the execution within the system, but no, it's also in terms of routing within the system, deciding which elements to listen to more. And if you think about the brain, that is probably what happens in the brain as well, because we have a part of the brain that becomes active when emotions are required. We have parts of the brain that become active when we are under stress, when we are thinking, when we are running. And all of these things, of course, interact to some degree and maybe reinforce each other even. But we have exactly this form of specialization, or what I like from Alora's perspective, contextual outperformance, that exists in the brain. And we're now just starting to enter this initial phase where we can start to try and capture some of these mechanisms in algorithmic form and start to leverage these same types of mechanisms in a decentralized context. And that is, apart from how far we can push that in the end, I think that is probably one of the most fundamental problems in current AI. It's actually to solve not just really the CPU problem or so, no, to solve the coordination problem so that things can just start scaling and start leveraging all of these different specializations.
Yeah, I completely agree. And going back to the sort of the original thing we started with, the leg and Hutter idea of being able to take the vast number of possibilities and possible solutions and narrow it down to the best the Occam's razor one.
Yep.
Being able to context awareness is absolutely fundamental here. I don't see, in this idea of a whole Earth networked scenario and having all the information available, being able to do that process, forgetting the physical limitations, I don't see how anyone could argue that that's not going to end up with an optimal solution if you're able to do that. And you're absolutely right. We thinking about my own responses, when if you're processing information, and there's emotional content, and you're talking about you're being maximally conscious and pulling in different ideas and different thoughts, and it's something that we naturally do, this context awareness, and choosing in a particular instance. So someone's cut me up on the road, do I get cross and beat my horn? That's one solution. Or no, I probably shouldn't. It could be my mother-in-law. There's, I think, your idea, the concept of Allora, and the conceptual, being able to make decisions appropriately, choosing from as wide a range of models as possible, is like an absolutely key step in this, moving forward, using decentralized intelligence to try and, I guess, make the best possible decisions.
Yes. Yeah.
So are you worried for the future? Do you think, in terms of ethical regulation, and where this is all going? There's a lot of discussion. Let's just say that a lot of discussion in social networks and in the media about AI, and some people saying it's already here, and some people are saying it's coming to get us. Where do you fit in all this?
I mean, I don't want to. I think it's very important to think about ethics and alignment and these types of things when it comes to any disruptive technology like AI is, right? In the end, humans, as a naturally curious species, end up doing most things because it's possible to do them without asking if they should. And um, there is therefore definitely the ability to, take things to a point where maybe you wouldn't want them to be. So I think responsible research is something that exists in any domain, really. And for AI, which has the potential to be one of the most disruptive technologies ever created, it is therefore an inescapable question how it affects ethics. And in answering that question, what is probably quite essential is to realize that AI is a tool. Many technologies, or maybe all technologies that we've ever developed, are tools. And those tools are developed to mostly make our lives better or easier or somehow add value to our lives. That is what innovation normally does. Sometimes it goes wrong. Sometimes you innovate something, it ends up making life worse. But you definitely can't say that all innovation makes life better for everybody, right? I think that is inescapably true. So in the end, there is absolutely a need to think about the development of AI in an ethical way that is necessary. The problem with that is, and then that's why I'm a little bit apprehensive and careful with how I phrase my answer to this question. The problem with that is that if I look at people responsible for AI ethics, then I wouldn't say that all of these people actually understand AI well enough. If you look at our conversation right here, we're people who work on AI every day, and we struggle with several of these concepts. And many of the questions we were discussing here, we didn't actually find a conclusive answer for, but nonetheless, we come to a sort of nuanced understanding, a conceptual model of reality that we claim provides some insight into the matter. But if policy is built on a misunderstanding of what AI is, how it functions, and what it could become, then you end up with very poor policy. So I'm definitely leaning in the direction that innovation and development should be left comparatively freely with the usual societal guardrails that exist without attempting to overregulate. If we do these types of things and at the same time enable people in a sense of enablement to handle AI the way that maybe somebody a long time ago had to learn how to handle fire when people started making their own fires. Um, now when we drive off in a car, we're sitting on a giant fire, right? Nobody thinks about it. But we're doing some highly explosive things there. I can't imagine that a similar form of sort of natural adoption in society of the unequivocally extremely powerful technology that AI is and will become, that isn't possible. I'm convinced that that is possible to do that well and to do that diligently. Unfortunately, as part of the high degree of connectivity, like we've been talking a lot about a free flow of information and connectivity and so on as a form of consciousness. Of course, as a society, we are evolving in such a direction, right? I still don't feel a hive mind. So very clearly, our societal connectivity is not enough to generate a form of meta consciousness. But of course, what that does is that there is a lot of there's a free flow of ideas and information, and that can maybe sometimes make people feel that they understand things before they do so, and people the connectivity generates a form of reinforcement where it is easy to stop thinking critically and instead say, okay, my three neighbors have told me that my perception is right, so it's probably right, and that leads to the wrong decisions. So yeah, long story short, I think guardrails are important. uh, Alignment is important. It's quite important that when AI starts to be able to control systems, then AI should act in the interest of its creators.
Yeah.
And that applies to any technology, right? As I said, is like we typically innovate in order to benefit humanity and these types of things, or at least that's the idea. Although
Yeah.
again, we often do things because we can, not because we should. But that is the essence. If we manage to do that, then there is no problem.
Yeah. No, I like that. So it's just ifs and trying to keep things in the right direction. I think everyone sensible would, I think, would agree with that. And yeah, let's keep things moving, keep things innovating, and keep things going in the right direction.
Yes, and this is important, right? Because there is maybe we forget that sometimes, but humans, according to our definition, are intelligent. That's the only real definition we have, and kind of a lot of the discussion we were having here has been about trying to formalize that one way or another,
Yeah.
trying to express that in sort of an objective way that is reproducible, can be understood, etc. So let's say we are intelligent. The fact that we are intelligent has transformed the world, right? We are looking at a world that looks completely different than it did even 100 years ago, but let's say 1,000. Um, Undisrupted nature doesn't exist that much anymore. It does, of course, in corners of the world, but we're looking at that type of disruption, which means that our ethical questions about what we do with technology go, potentially a lot further than just about interhuman interaction.
Yeah.
And very soon, it will probably also relate to interplanetary ethics. So I think it's important in this sort of consideration to consider ethics on all possible different levels and all possible different manifestations thereof. And that is something that maybe we're not quite ready to do yet, because we struggle to oversee the implications of these types of technologies.
Yeah, that's very, very difficult. So you mentioned, I guess, some idea of evolution and development there. I think that's something that we were going to cover and haven't. Is there anything to go back to on that?
Um,
Yeah, just before we wrap up. So we've had this sort of narrative arc of starting from trying to understand what intelligence is, how humans have developed it, how it could differ between sort of AI and humans. We've talked about the evolution of the brain and perhaps consciousness and intelligence being sort of happening at fairly similar times. So there's definitely a sort of evolutionary arc here.
mhm.
How do you see that going towards the future?
Well, we definitely need to keep asking these critical questions about what intelligence is, right? Because
Yep.
um, because you can now you can start defining different kinds of systems that mimic what we perceive as intelligence, um, and because these systems arose differently than intelligence did in life, maybe consciousness doesn't co-evolve in these systems the way it did in life, right? So then you end up with systems that aren't conscious but are intelligent, and that is something that we've never seen before. I think that is probably something that describes the current state of AI. And we've I think in this conversation also touched on why consciousness is so important and why potentially even embodiment is so important. So yeah, the direction this might evolve in is hard. I think we need to try to identify the things that are missing in AI and use these sort of formalized concepts that we have of these missing ingredients to try and come up with workable algorithmic representations of these within the general AI infrastructure that we are building. If we manage to do that, then we're actually looking at the potential to realize actual intelligence in an artificial form. Now, whether or not that is something we should do
Yeah,
is a different question, of course, right? Because at that moment, you are, in part at least, you are creating intelligence. If you're also creating consciousness, then also ethically you enter a very slippery slope. So
yeah,
these are fascinating questions to me, and I think the yeah, maybe the way to express this is that the implications and ramifications of what intelligence is go further than we thought, and also what constitutes intelligence might transcend the individual.
yeah,
Like we saw that in the termite example, for instance, right? Is
yeah,
these termites have some genes that determine how they function, but in the end, it is actually their collective behavior that defines something that we would be a lot more likely to call intelligent than their individual
yeah,
behavior. So,
yeah.
um, so very clearly, we need to think about this in a very original way, and that is that's the ongoing challenge.
Yeah.
Yeah.
Good. So I have one more question. So I think just to sort of wrap this up, how do you think all the things we've been talking about and these perspectives on intelligence are going to change as AI itself develops? I see there's an interesting kind of step. So our understanding of intelligence is changing as time goes on. How do you see that progressing?
Um, we are looking at a development where AI becomes multifunctional. So it can become an agent the way humans are. It can start to engage autonomously in decision making the way humans do. And we can start thinking about, therefore, also, like if you look at the more decentralized forms, we can start to look at distributed decision making. We need to think about how these types of autonomous agents interact. We need to think about the rule sets about how they interact, not just with humans, but also with one another. We need to think about um, the incentive structures and the games that we can basically let these forms of AI play. And that is a very challenging design step. And again, it is because we're approaching this sort of meta level of intelligence, which is in many ways like a different way of being. And when we're reflecting on these types of things, it's important to realize that intelligence has kind of always been a moving target. It's not just a moving target now, also historically, right? As as intelligence evolves, as technology evolves, we change our perspective on how we define intelligence and how we understand it, how it manifests itself. And what that means really is intelligence has always really been shaped by the more biological, the social, and the technological constraints of its time. So we are now forced to think carefully about all of these things: what intelligence means, how it functions, how it emerges, whether we can generate artificial intelligence, and then how we structure, incentivize, and integrate that into society. That is kind of what we are discussing here today.
Yeah.
And this shift towards decentralized intelligence that we now see adds a whole other layer to that transformation, because now we don't have this single system that dictates the trajectory of artificial intelligence, but we're seeing this sort of emergent paradigm where intelligence is distributed. It can be self-improving through the mechanisms that we discussed today, but also in the previous episode. And it can be shaped by many contributions, not just a few. And that is really important, because we shift. It means that intelligence is no longer just about computation, but about coordination. And the real challenge isn't simply to build machines that are somehow smarter, right? Whatever we think smart is. But it's about designing the frameworks that somehow allow intelligence to emerge, evolve, and function in ways that we can trust. And that again relates to consciousness, right? It's not just intelligence, it's also the question of how consciousness, which is, as we said, is kind of the other side of the same coin in a biological context. If you look at biologically evolved intelligence, consciousness is just sort of that flip side. Now it's not clear if it is. And we need to think about how intelligence functions without that, without embodiment, or maybe even with them once we start putting these in. And this is a complex journey where we're really only at the beginning of all of that. And it's important to realize that we must cut through this noise that exists in the world in general, but also in this ecosystem where some people see AGI in the current state of affairs, which fundamentally might just be a very capable interpolation machine. But then others are on the other side of the spectrum, and they hold these very rigid axioms or deeply ingrained assumptions about what intelligence is. And that probably isn't right either. And if we want to make real progress in the right direction, to actually start understanding intelligence in the artificial intelligence age, we absolutely require critical thought. We maybe even require some healthy dose of initial agnosticism, because there are many things we actually don't know, and there is a good chance that on timescales as short as the next decade will be challenged in terms of how we think about the meaning and the nature of intelligence. So I think this conversation is far from over.
Yeah, it's far from over, but I think we're going to have to wrap it up there. This general perspective on the nature of intelligence and what AI really means. So thanks very much, Diedrich. I really enjoyed that exciting discussion, learned a lot.
Likewise.
Yeah, in particular, I think, we'll see in the future so how AI, is comparing to human intelligence and in relation to consciousness and embodiment. And really, I think you're absolutely right. The next decade is going to reshape our understanding of intelligence. So if you'd like to explore these ideas further, please do check out our research at allora.network and stay tuned for the next episode of the Allora Research Fireside Chats.